So looking at our second example, you're going to see that I've changed the information down here on the bottom to help us find something to solve for it. So we know that we have this initial kinetic energy that, remember, kinetic energy is 1/2 mv squared, and we're going to have that initial velocity. And at the end, because it's going up a hill, right, all that kinetic energy went to gravitational potential energy, which was mgh. Well, in this simple case where we have mass on both sides, we could actually cancel that out and leave out the 2 kilograms in the problem. I'm going to go ahead and put it in just to put it in, but you could mathematically cancel that out. Okay, so our car that has a mass of 2 kilograms is initially moving at, it says, 2 meters per second. Make sure you square that value. And then once it coasts up that hill, and it says that there's no friction, so we have no dissipated energy, our 2 kilogram mass times the acceleration of gravity. Remember, all energy is scalar, so we don't use any negative values in there, so we just leave that as a positive 10. And it reaches what height? And that's what we're solving for. So initially, if we take the point, or the half, or so 0.5 times 2 times 2 squared, that gets us 4. So initially our car has 4 joules of energy, which means if energy is going to be conserved, when it gets up to the top of the hill, it's going to also have 4 joules of energy. It's just going to be of a different type. So 4 divided by 20 gets me 0.2 meters. So our car reached a height of 0.2 meters. So that one's pretty straightforward. Let's look at 2b and see what happens when our system changes. Now in this problem, it says that there's friction. Well, looking at the picture, it looks like it reaches the same height, so my gravitational potential energy remained the same, but now I needed this dissipated energy. Well, the only way that can happen is if my car initially was going faster than it was going before. And so that's what we talked about in class, about making that diagram work. Well, for the sake of the problem, when I started adding these values in here, what you're going to see is that I actually changed that height. That you see that up in 2a, it reached a height of 0.2 meters. Well, now I'm saying it only gets to a height of 0.1 meter, and that velocity stays the same. So I kind of changed it a little bit from what we talked about in class. So let's see. We want to know if the total distance that it went up the incline is 0.2 meters, what is the force of friction? So that 0.2 meters is saying that this distance here is 0.2 meters. Well, we know we have that kinetic energy, right, that 1/2 mv squared, and when we, before it was just equal to gravitational, but now we know that friction is doing work, and remember, work is force times distance. So the frictional force times the distance that that force is applied is equal to the work that it does, and then the ending result is this gravitational potential energy. So the 1/2 mv squared, that's just like before, 1/2 2 times 2 squared, and that got us the same initial energy of 4 joules. But now some of that energy is going to be taken out. Well, if we're looking for the force of friction, right, remember that the force that does work needs to be in the same direction as, or not in the same direction, but parallel to the distance. Well, the distance and our slope is here, so our force needs to be parallel to it, and that is what would happen as the cart's going up the hill, right? Our force of friction would be parallel to the slope, but down it. Okay, so I can find that force of friction if I put in our distance that it traveled, and it says that it traveled 0.2 meters up the incline. That's equal to our gravitational potential energy. It's a 0.2, not a negative. So that's equal to our gravitational potential energy, so 2 times 10, and it gets to a height of 0.1. So we know that when it ends, if we multiply that together, 2 times 10 times 0.1, right, what does that get us? 2 times 10 times 0.1 gives us 2. Oh, duh. So there's only 2 joules of energy left. So that means that 2 joules of energy must have been dissipated from friction, right? So if, mathematically, if we're going to figure it out, we're going to have 4 minus 2 equals force of friction times 0.2, and we can solve for that force of friction and find that the force of friction in this case is 10 newtons. Hopefully this one helps also, and there will be one other one that might help you out a little bit also.